Hello everyone and welcome. My name is Aftab Mandal and in this video I'm going to talk about JDK Environment, which includes JRE's environment, and we will also cover what is JVM's architecture. So JDK is a development kit which provides all the necessary tools and binaries to execute our code, which includes JVM, JRE, and various tools like compiler, debugger, and document generator, which helps to execute our code. Now, if you talk about these components in brief, so the first one is JRE, which provides a runtime environment. It does not have any tools to execute the code, but it provides the environment and it provides all the files in binaries and libraries which is required to execute our code, and it makes sure that our program runs smoothly. So also JRE consists of JVM. Now this JVM is included in both JRE and JDK also. The JVM which is included in JDK is responsible for executing for developing the code, and the JVM which is inside JRE is responsible for executing the code. Now, if we talk about how compilation is done in JVM in Java, so first whatever we write the code is in .java file. This Java file then gets compiled into the .class file with the help of compiler. Now, as an input, JVM takes this .class file and and then we enter into the JVM architecture. So this JVM, we can also say that it is a heart of Java programming, which actually executes the code. So it receives a .class file and then it starts working on it. So in context of architecture, we have three components which actually execute the code. In first, we have class loader subsystem, which has three subclasses. So the first one is class loader. By the name itself, it is known that it will load the classes. So it will simply load the classes into this JVM, which will be executed further. So in this we have three types of class loader, like bootstrap class loader, which is responsible for loading Java's archiver files, like we have strings or utility class and many files. So this bootstrap class loader is responsible for for loading Java's archiver files. Then its child class loader, which is extension class loader, which will load .ext file. And then finally we have application class loader, which will load the class which we created. And that was all about class loading. And then we have linking phase. In this linking phase, we have again three systems. Like in this linking, it will be checked and verified whether our code is structurally correct or not, or it will check whether our whether our code is come through the valid compiler or not. The second phase will be the verification. Verification was this part. The second will be that preparation. In this phase, it will assign the default values to the variables. And then we have resolution. In this part, it will replace the symbolic representation, meaning whatever the .class file was in symbolic forms, it will replace those symbolic into the original values, which further will be implemented with the JVM. And then finally we have initialization, which in this phase the original values will be assigned to the variables and our code will be executed from top to bottom. And then we have memory areas. So after successfully loading the class, then it comes to the memories. We have 5 types of memory in Java. So the first one is method area. So this will be loaded at the startup. In method area, so various static classes and all the static methods and class will be loaded into the method area. From this, we have heap memory. So all the local variables or the objects which we create will get stored in the heap memory. And then we have stack area. So the number of stack areas will be created at different threads. So this is also will be created at the runtime or at the startup of Java. So the stack area consists of the variables which has the references of those objects, and also the local variables will be stored inside stack area, and the instance variable will be stored inside the heap memory. And then we have Java's native method, which will store the native interfaces. And then we have finally PC register, which will count the threads which is to be executed and which method is to be executed at the moment. So it keeps the count of all those methods which is to be executed. So that was all about method area. And then after all this process, we have execution engine, which is the main or most important part of JVM or Java's JDK's kit. So in execution engine, the actual bytecode will be converted into the machine code, which will be then executed by our machine. So in execution engine, we have interpreter, which will interpret our code line by line. But the problem here is, if a function is repeatedly called, or if a method is very frequently called, so this interpreter will again interpret that particular code line by line again and again. This will impact very much on our efficiency. To solve this problem, we have JIT compiler, which checks that if a method is frequently called, so it will took that part only and it will compile further into native, which it will compile that particular code into native so that it can be understandable to our operating system. So it will compile that particular code into machine level code or more basic level code, which can be understood by our system's operator. So in this way, it helps the interpreter to execute the code and more efficiently. And then we have garbage collector, which automatically deallocates the memory which is not used or which has no reference in it. So it saves our memory at this point. And then we have Java native interface, which helps to, if a code is written in other particular language. So Java native interface will provide a medium to execute that code which is written in other language to execute in our Java's code. So that was all about my side. I hope you learned something new in this video. In summary, all I want to say is JDK, JRD and JVM, all these three are very important components in Java, which understanding these three is a must for a Java programmer. And I hope you learned something new. My name is Aftab Mandal. I will see you in the next video. Until then, goodbye.